Welcome back to GATE XAIML. So now we'll see two more distributions which are helpful in statistical analysis. The first one is students T distribution. The other one is chi-square distribution. So what is students T distribution? So we'll not go into the depth like what is the mean value, variance, what is the probability density function and all, because we'll not be using that. Here we are only interested in how it helps in estimating the population variables. Okay. So if you remember the second chapter, I told what is the entire statistics about. You have a population. From that population, for that population, you need to estimate some parameters, say mean and variance, something like that. And then for that you take the sample, and then you from the sample you estimate, and then say that this is the good fit for the population parameters from the sample. But how will you say it? How good it is? So to test that, you usually use student T distribution and chi-square distribution. So the confidence intervals and all those things we'll learn in the next chapter, but just we'll introduce with these distributions. So basically, we'll see their uses. The student T distribution is used when estimating population mean from small samples or unknown population standard deviation. Let us say this is your population. Assuming that the population is known, the mu, that is mean, the population is known, so you can estimate some variance or some other statistics. Okay, so you can test how good is our sample mean or this standard deviation or variance. So for that you can use the t-test. That's what they say. When unknown population variance is okay, standard deviation variance, this is not known. So how will you calculate it? And once you calculate what is the accuracy, for that you use this test. Okay. More on this in next chapter. Okay. So what are the key points? The T distribution is also symmetric, just like these are all the derivatives of your normal distribution. So in the central limit theorem, I will explain what exactly and how they look in detail. So they are symmetric and bell shaped, just like normal distribution. They are heavier tails for small samples. Approach is normal as sample size increases. Okay. So just understand this. In the next chapter, I will explain in depth. Then the concept of degrees of freedoms come here. So I used this concept in the second chapter also when I calculated your sample variance square. So we'll come to this shortly. Okay. T statistic. What is this T statistic? How will you get it? So based on this only you are going to test. You conduct some tests. So it is given as sample mean minus population mean divided by sample standard deviation divided by square root of sample size. So it uses one sample, two sample paired t-tests and confidence intervals for mean. Okay. It is used for those reasons. Now we'll try to understand degrees of freedom, what it exactly means. In the second chapter when I explained, I told you I will explain the degrees of freedom in the later part. So we have come there now. I will explain why. You remember you used S square, that is variance of sample is divided by n minus 1, whereas the variance of population is divided by capital N, that is size. But here 1 was subtracting from the sample size y. So that is the concept of degrees of freedom. So what is the definition? Let us say the textbook definition. Degrees of freedom refer to number of independent values in calculation that are free to vary without violating any constraint. Okay. I'm sure that you have not understood this. Okay. Let me take the example. We'll see the degrees of freedom and why, as an example, why it is divided by n here and why it is n minus 1. So to understand this, first let us understand the degrees of freedom. Now let us say this is my population, size n. This is the entire population. Population size is capital N. Sigma square is the variance, mu is the mean. Now I derive a sample This is my sample, and then say sample size is n. Sample mean I calculate as x bar and variance is s square. So while calculating this, there is a concept of degrees of freedom. Degrees of freedom means how many variables can be independent. Okay. So let us take n is equal to 3. N is equal to 3. Simple example. Now say that x bar I want it as say 6. Sample mean is 6. Now how many variables are there? x1, x2, x3. 3 variables, n means 3, right? Sample space has 3. So 3 data points, x1, x2, x3. Now x1 plus x2 plus x3, okay, divided by 3 is equal to 6, right? Now let us say I will choose x1 equal to 1, x2 is equal to say 11. Okay. Now two variables I have chosen. I can choose any values here, right? I can choose, for example, say x1 equal to 3, x2 is equal to say 18, right? Now, but I should get the mean as 6. This is my x bar, right? You get as 6. These x1, x2 can take any values. That means they are varying. They can be varied. They are varying, independent. They are varying. I can vary this too, right? Now, for this, what should be the x3 values? Such that I'll get 6 as the mean. Are you getting the point? Now, so 11 plus 1, 12. 12. If I take x as 6, so it is 18 by 3 is 6. So x should be 6. x3, it should be 6. I cannot take any other value than 6. If I take any other value, then I will not arrive at this value. Here, similarly here, x3 should be minus 3. I cannot take any value because these two already I have fixed. These two values. They can take any values. Okay, but this one I am fixing it to take this particular value only. These two values, these two x1, x2 can take any values. x3, but give them freedom here. This is the freedom I am giving, right? This is the freedom I am giving for x1 and x2. But there is no freedom for x3 because I have to get this mean value. So this is the concept in statistical analysis. Now, so one variable I have to fix. So how many are there? N equal to 3 was there. 2 I can choose. 2 are free. They are free, right? They are not fixed. They are free. And 1 is fixed. That means what? N minus 1 are free. 1 is fixed to arrive at this mean value. Because this mean is calculated from the sample. Okay. So for the correction, when I do it for the estimate for the population mu, then this one value has to be adjusted. This x3 here in this example has to be adjusted. That's why we say the degrees of freedom is n minus 1. This is called as degrees of freedom. It is the concept of degree of freedom. When you calculate some value and from the sample, n minus 1 can vary, but 1 I have to fix to take to match what I am calculating. So that is the concept. Because when I estimate something, I need to vary one variable so that I will get that value. Otherwise, it will lead to some other estimation, some wrong value estimation. That is the concept of degrees of freedom. Now, why it is, that is the reason why I divide it by n minus 1. So, xi minus x bar, to take, see, if you remove this square, just add them. I equal to 1 to n, xi minus x bar If I do this, I'll get 0. I'll get 0. Since there is a square, I'm getting the variance. So it will get 0. You can try it. So that is the reason why I have to fix one value such that I will get 0. Otherwise, I will not I will not get to this. This is a concept. That's the reason why I am dividing by n minus 1. 1 is fixed, n minus 1 are free. So I can take these xi values, x1 up to say xn minus 1, they are free. I can give any values, but to make this 0, this has to be 0. Okay, this is called as unbiasedness. Unbiased. To get this 0. To get that 0, the last one should be fixed. Based on the values these take, they assign a value to this. This is fixed. So these are varying. That is the concept. That's why we divide it by n minus 1 degrees of freedom. Why it is n here, not n minus 1? See, because already this is known. The population, this is why you are finding this, is because you want to estimate the population mean. But when you already know the population mean, then there is no need, because this is not fixed. This value already you know. Here I don't know this value. That is the reason. Take this example. I want to calculate this value. To get this value, I have to fix this variable and vary these variables. But already when I know this value mu, so I need not fix that one variable. All we can take any number of values, because I already know this is the mean value. That is the concept. Let us take an example. A dietitian wants to check if average weight loss of 10 people differs from 3 kg. Sample mean equal to 2.5 kg. Standard deviation is 0.8 kg. Find the t-score. The more testing and all those things, we will do it in next chapter using confidence intervals. Here we will just only calculate the t-score. So what they are given, n equal to n. Okay. Sample mean they are given it as 2.5. Standard deviation, sample mean and sample standard deviation is given. Okay. This is given as s equal to 0.8. So differs from 3 kg. That means population mean is also given. So t of n minus 1 you have to find. This is n minus 1 degrees of freedom, because you are fixing 1 degree of freedom. So this is nothing but x bar minus mu divided by s into square root of n. What is x bar? 2.5 minus 3 divided by 0.8, sorry, divided by square root of n, square root of 10. This we will get it as minus 1.976. So t of 9 degrees of freedom, t df equal to 9, you get minus 1.96976. Now for this again we will have some probability values. CDF values will be given, like your z score. This is the t score. This is called as t score. So for this again there will be a table, lookup table, where you can get the probability value for this. And then you will use that probability to test whether the whatever I calculated this is a good estimate for this or not. That is what we are trying to say. Okay. Same example. N equal to 15. Mean lifetime is, means x bar is 520. Standard deviation s equal to 25. Population mean is equal to 500. So t of 14, so n minus 1 is 520 minus x bar is, so x bar is 520, minus 500 divided by s is 25 divided by square root of n. So this comes out to be 3.10. So for this you will find some probability values, and then that probability values will be used to test whether your estimate is good or bad. Okay. Next. So similarly, chi-square distribution. is actually used for variance and categorical data to test the variance in the categorical data. This actually is again the same thing. If for small degrees of freedom, that means for small sample size, it is usually skewed. Even the t distribution also skewed. Both chi-square and t distribution tends to normal, approaches normal distribution. They become like normal distribution only when this degrees of freedom or sample size tends to infinity. And n tends to infinity, sample size tend to infinity. See, the t or chi-square is written like this, chi symbol. Chi-square tends to normal. This is how, this is the concept. This is the concept of the central limit theorem that I will explain in the next chapter. So what are the uses of this chi-square distribution? The first one is for variance testing. This is the chi-square statistic. Okay, like t statistic and g score, g test, t test, chi-square test. All this will conduct to test our data. So this is given as n minus 1 s square divided by sigma square. S square is, this is sample variance. This is population variance. So it is used for goodness of fit test, test of independence in contingency tables, confidence intervals for variance, part of ANOVA, that is analysis and variance test. Let us see an example. So a sample of 10 machines, so n equal to 10 as a variance. What is the variance? S square is equal to 16. Calculate the statistic if population variance is sigma square is equal to 9 using chi-square test. What is the statistic says? Chi-square n minus 1 degrees of freedom again. Here it is given as n minus 1 into s square divided by sigma square. This is chi-square. So degrees of freedom is 9. Okay, we write df equal to 9 degrees of freedom equal to 9 into, what is s square? 16 divided by 9. This is equal to 16. Again, for the chi-square distribution, for 9 degrees of freedom, you will have some values, probability values. Okay, from that again, that values indicate whether your test is successful or not successful. Okay, or the test successful means what? Whatever are estimated is a good estimate or not. That is the basic concept. So in the next chapter, we'll see the concept of central limit theorem, that is how and when to apply these tests. Okay, and then you will see the confidence intervals. That will complete your syllabus GATE DA. There are many more concepts which they are not introduced, so I will take them as separate classes, not as part of GATE DA syllabus later. Thank you for watching. Please like, subscribe and share with your friends.